Hello, very good afternoon to all. I'm Vivek, and today basically we are going to discuss the paper, right? So today we are going to discuss our second paper that was held on 14th of May, right? So let's see some difficult problem in which you face some problem while solving the question. So I'm going to explain you in a detail what type of question that really some difficult to solve and what are the best procedure to solve such questions, right? So let's start with the today's session. I hope my voice and my voice is audible to you and my screen is also visible to you, all right? So if you find any problem, then you can just text me. I'll correct this, okay? So the first question is that is during the electrolysis, this question is from electrochemistry, that is Nernst equation, right? So what is the equation? What is the question is all about? During the electrolysis of 0.1 molar copper sulfate solution using a copper electrode, a depletion of copper plus occurs near the cathode with the corresponding excess near the anode. Owing inefficient stirring of the solution, if the local concentration of copper 2 plus near the anode and cathode are respectively this, calculate the back EMF developed at temperature 298 Kelvin, where the log 2 and log 3 values are already given, right? So we know that how will you actually calculate the back EMF in case of by using the Nernst equation. So how will you calculate this better? Basically, for question number 19, so if you want to calculate the back EMF, what is the formula that we use for the back EMF? That is, this is nothing, but this is equal to 0.0591 and divided by what? That is N, right? So divided by N, and this is log, and this is the concentration, right? Concentration, and near the anode and cathode concentration were given, right? So this is the concentration, right? So we have to use this. Now, what is copper sulfate? So we know that in case of copper sulfate, copper having plus 2 charge. The value of N is nothing but it is equal to 2. So it is equal to 0.0591 and divided by 2. What is this log here? This is log. What is cathode and what is anode? So we know the value of cathode, that is 0.12 and 0.018, right? So this is the value of the product, that is 0.12 and divided by 0.08. Okay, so just solve this value. We know what you'll get when solving. You'll get 0.295, right? 0.0295 into this log comes out to be log, I just solve this, so it will comes out to be log 12 upon log 8 into, yeah, 10 raised to the power 2, 10 raised to the power 2, they are cancel out each other. So it comes out to be log 2 and this is log 3. So given that log 3 and log 2 values, so this is nothing but 0.0295 and this is log 3 minus log 2. So just put the value, that is 0.0295 log 3. The value of log 3 is given, that is 0.477 minus 0.301. So what you will get, that is 5.2 millivolt, right? So correct answer is D. So I hope this is very simple question and you just need to know the formula. If you know the formula for this question, then you can easily solve this question, right? So this is how we can solve the question. I hope it is understand. सबको समझ आ गया? ठीक है? चलो. So what is the next question basically? So in the next question, they are asking incorrect statement out of the following. So you have to identify the incorrect statement out of the following, right? The first one is Palissy test is used as a qualitative test for the organic halide, right? So this one is very much true because in the test qualitative analysis of organic halide, we use the Palissy test, right? And the similar xenoprotetic test is used to detect the presence of amino acid carrying aromatic group, or we say benzene ring. This is also true. Barford test is used to detect the presence of monosaccharide. This is a carbohydrate, right? So this will use in carbohydrates. Any HSO3 is used to identity C2H5CO C2H5, right? So this is sodium, sodium hydrogen sulfide test. So this is not used to actually identify the ether group, right? So this is the incorrect statement out of the following. So which option is incorrect? That is option number D. So option number D is absolutely incorrect out of these four values, right? Now, you have to select the right one, right? That is in this question, they are asking, you have to calculate, basically, select the correct statement, right? A d orbital can accommodate 8 electrons, right? A d orbital can accommodate 8 electrons. So we know that any orbital can accommodate only 2 electrons on it, right? Total d subshell having 5 orbitals, so they can accommodate 10 electron. But if they are talking about the d orbital particular, so any d orbital or any p orbital or any s orbital, they can accommodate maximum of 2 electrons only. So this statement is absolutely wrong, right? Now, Na, that is QS1 ionization enthalpy 1, Na because the ionization enthalpy 2, Na2 ionization enthalpy this. Now the order of successive ionization enthalpy, this is given IE1 is less. Yeah, this is absolutely true. IE2 and IE3. So IE3 is greater than IE2. This is not, IE2 is greater than, right? IE2 is greater than IE3, right? So you have to identify. So we know that successive ionization enthalpy gets very, very difficult, right? So if I'm talking about the successive ionization enthalpy, so it is very difficult to remove the electron. So if I'm talking about the ionization enthalpy of the third element, that is Na plus 3, so this having a more electronic ionization enthalpy as compared to 2. So this order is also incorrect. Always remember that successive ionization enthalpy always increases. Now, if I'm talking about the number of unpaired electron of CO2 plus cation is greater than number of unpaired electron in CO plus 3. So let's see. CO belong to CO having a atomic number, that is science teacher very cruel mange fair copy. That is 3d7. So cobalt in plus 2 form, they are 3d7. Similar cobalt in plus 3 form, they are nothing but 3d6, right? So they having unpaired electron. How much they having unpaired electron, beta? So we know that d orbital having d subshell having 5 orbital, 1, 2, 3, 4, and 5. So 1 electron, 2 electron, 3 electron, 4 electron, 5 electron. This is 6 electron, this is 7 electron. So total we have n is equal to 3. The total 3 number of unpaired electrons are present in this. Similar, if I'm talking about this, then we have a electron 1 2 3 4. So we have a 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, 6. So we have a n is equal to 4 electrons. So total number of unpaired electron in CO plus 3 is 4, and in CO2 plus it is equal to 3. So total number of unpaired electron in CO2 plus atom is greater than the total number of unpaired electron in CO plus 3. Right. So this is absolutely wrong, because in a CO plus 3, n is equal to 4, and CO plus 2, we have n is equal to 3 only. So this is also incorrect. So what is the correct option? That is the nothing but D. D is the correct option. How? Because the first ionization enthalpy of zinc is greater than that of copper. How is it possible? Because if I'm talking about the copper having electronic configuration 3d10, 4s1, and zinc having electronic configuration 3d10, 4s2. So obvious, the first answer for zinc is greater, because if you want to remove electron from this is a fully filled, right? This is a fully filled s electronic configuration, where this is a half filled s1. So this one electron is easily removed. So we can say that the ionization enthalpy of zinc is more as compared to the copper. If you're talking about the first ionization enthalpy, then obvious the correct statement is D. So this is very good question, and it is basically from the periodic classification. So if you know the concept behind this, then you can easily solve this question, no issue. Now, the next question is you have to identify the correct order, right? So the correct order in this question, covalent character. So for covalent character, what we use Fasan rule, right? So for the covalent character, what we use Fasan rule, nothing but Fasan rule. So according to Fasan rule, Fasan rule. We use Fasan rule. So what is according to Fasan rule, beta? So we know that according to Fasan rule, charge of charge on cation must be more and charge on anion must be low. So if if the following compounds follow this order, then it must possess a covalent character. So if I'm talking about MgCl2, Mg having +2, calcium also having +2, strontium +2, and Ba +2. So all they having a +2 in charge, right? So let's now we can see the size, because when the size difference between the cation and anion is very large, when the cation of smaller size show covalent character, right? So out of these, which are smaller in size? So we know that beta Mangekar, that is Mg. So Mg are smaller. Right. So this statement is absolutely correct. Right. So this statement is absolutely correct because they are arranged according to the size, magnesium having a lower size and the beryllium having the highest size. So the covalent character of magnesium chloride is much more as compared to barium chloride. So this order is absolutely correct. Now, the next one is basically that is thermal stability, right? So we are talking about the thermal stability. So what is the thermal stability order basically? If I'm talking about PbF4, PbCl4, PbBr4, and PbI4. So here Pb is common, right? Here Pb is common, but in case of F may more electronegative, so they are highly stable. So PbF4 is highly stable and PbI4 is the less stable. This one is also correct. So melting point as we know that Kf, KCl, KBr and Ki. So this also follow the correct order. Now, if we're talking about the boiling point, we know that boiling point of noble gases are very low. However, their boiling point increase throughout the group when increase in the van der Waals forces. So basically, the boiling point increases as we move down the group because on moving down the group, the van der Waals forces start increasing. So the expected boiling point of xenon would be more than the krypton, and krypton having more than argon, and neon having more than helium. So this is the incorrect. So this is only the incorrect order of this out of the four questions. This one is only the incorrect order, right? So the correct order for this question is that is the incorrect order for this question is the boiling point order, right? Because these boiling point order are arranged in a wrong way because we know that boiling point as the as masses increase, as the molecular masses increase, van der Waals forces also increases, and due to this, this will happen, right? So this is the incorrect order. I hope this is clear to you. Okay. Now, the next question is, which of the following reaction will proceed into benzene? Right. So which of the following reaction will produce benzene? Right. So you have to identify the which of the following reaction will produce benzene and all. Right. So the correct answer for this question is basically beta. This will that is reduction. Right. That is when the this one is very famous reaction. That is when the ethylene is treated with the red hot iron, right, at a higher temperature, almost about 6 degrees Celsius something. Then the formation of benzene will take place. So in this, the formation of benzene takes place. So this one is absolutely correct. In which benzene is formed. And the next one is this, right? So in this also, when BTC is under treated with 3PO2, then also formation of benzene will take place, right? Okay, so this is how will you get benzene. Basically, in this reduction process, in this you'll get aniline only, right? So you'll get aniline only, NH2, right? In this also, reduction will take place and you will get aniline. So it's only this process, these two process in which you will get benzene. So this is very simple reaction. So we know that whenever the ethylene is treated with the red hot iron tube under a very high temperature, then we'll get this, right? So this is all about what we get in the following reaction. Okay. So I hope this is very much clear to you all. Good. Right. Now, The next question is you have to identify incorrect match option out of the following, right? So you have to identify the incorrect option out of the following. Let me check whether we'll discuss this question or not. Yeah, we'll discuss. So incorrectly match option out of the following. So which of the option is incorrectly matched, right? So in the list one, we have a maltose, amylopectin, 4-hydroxyproline, and thiamine, that is nitrogenous base. So you have to identify out of this, that is presence of beta 1,4 glycosidic 1,4,6 glycosidic linkage, right? Presence of beta 1,4 glycosidic 1,4,6 glycosidic linkage. So we know that in case of amylopectin, right? In case of amylopectin, we have a we have a presence of two like cross linkage are present, like presence of beta 1,4 glycosidic linkage and 1,6 glycosidic linkage are also possible. So let's see if we see the structure, right? So incorrectly match. Which of the following is incorrectly match out of this following, right? So let's see which one of the following has an incorrectly matched. Now, if I'm talking about a structure of lactose, so A, what is A here? A is maltose, right? So A is here is maltose, and it is basically and B is amylopectin. So instead of beta 1,4 glycosidic, it should be alpha 1,4 glycosidic. So always remember this thing. Instead of 1,4, right? Instead of beta 1,4 glycosidic linkage, it should be, it should be, what it should be? It should be alpha 1,4 glycosidic linkage, right? Okay, so instead of beta 1,4 glycosidic linkage, it should be alpha 1,4 glycosidic linkage. This one is important, right? So this one is wrong. That is B. Okay, so the B amylopectin. So we can say that the B is absolutely wrong. Similarly, if I'm talking about the next one, that is D. So D in the thiamine. So thiamine is a pyridine, not purine, right? So thiamine is pyridine, not purine. So incorrectly match option out of the following are, that is A, right? That is A, B, and D. So A, B, D are the basically the that is A, B, and D. These are incorrectly matched, right? So they are maltose is correctly matched, absolutely correct. Structure of lactose, right? So they are absolutely correctly. They are the sorry, they are the not correctly matched because they are the structure of lactose only, right? So they are the structure of lactose, not maltose. So this is the structure of lactose. So this is incorrectly matched. Amylopectin. This is 4-hydroxyproline. So it will give positive test with NaN2HCl. This is correct, right? So this is correct. So which of the following option out of the following is the incorrect beta? So the option number A, B, and D. These are correct. That is A, B, and D. These are the incorrect option. Okay, good. Now, a reaction can take place by the two path K1 and K2 are rate constant for the two path. This question is from chemical kinetics. And E1 and E2 are their respective activation energy. At temperature TA, it is given that K1 is greater than K2 and E1 is less than E2. If the temperature is raised to TB, the rate constant changes to K1 dash and K2 dash. Which relation is not correct between K1 and K2 and K1 dash and K2 dash considering the activation energy? So in this question, what they generally say at K1 and K2, right? We have a no, we have a two activation energy, that is E1 and E2, right? So a reaction can take place into the two paths K1 and K2. So either by K1 or through K2. Their activation energy is given, that is E1 and E2. So if it takes place through K1, its activation is E1, and if it takes place K2, its activation energy is E2. Right? At temperature T1, K1 is greater than K2. So at temperature TA, K1 is greater than K2 and E1 is less than E2. This is given at temperature TA. At temperature TA. So at temperature TA, K1 is greater than K2 and E1 is less than E2. This is already given. Now, if the temperature is raised to TB, the rate constant also changes to K1 and K dash, right? So if the temperature is changes to TB, K1 is changes to K dash 1, K2 dash. So what is the relationship between EA and EB, right? So which is the correct between K1, K2 and K1, K2 considering activation energy does not change with the temperature. So you have to consider this activation energy does not change with the temperature. It means here also E1 is greater than E2, right? So if we assume that their activation energy does not change and you proceed with the two paths that are either with K1 and K2. So at temperature TUA, K1 is greater than K2 and E1 is less than E2. At temperature TB, K1 is become K1 dash and K2 become K2 dash, assuming that there is no change in the activation energy. So what is the correct relationship between this, right? So which is the correct relationship between? Let's see. So we know that how will you solve this? We know that from the Arrhenius equation, that is K1 is nothing but A e raised to the power minus E1 upon RTA, right? RTA. Similar, what is K2 beta? So K2 is nothing but again AE minus E2 upon RTA, RTA, right? Because this is the K1, K2. Now what is K1 dash and K2 dash? So K1 dash is nothing, but it will become AE. This is minus E1 upon RTB. Okay. And this is K2 dash. AE minus E2 RTB. Okay. So just divide this K1 by K1 by K1 dash, right? But you'll get this. So you'll get this K1 by similar one K1 divided by K1 dash. So what you will get, just cancel the same values. So you will get nothing but E minus E1 upon R 1 upon TA minus 1 upon TV. So K1 upon K dash 1 is equal to AE minus E1 upon R, right? TA minus TP, right? So this is what you will get. On the similar basis, right? So this is what you get in this. On the similar basis, what is K2? What is K2 dash upon K2? So it will comes out to be E minus E2 upon R 1 upon TA 1 upon TV, right? So 1 upon TA minus 1 upon T. Now it is given that from the question itself, it is given that what is given that beta? So from the question itself, it is given that E1 is less than E2. So E1 R 1 upon TA minus 1 upon TB less than E2R 1 upon TA minus 1 upon TB, right? So we can say that K1 dash upon K1 is less than K2 dash upon K2, right? So this is the relation that will get K1 dash upon K2. So which of the following is correct option out of these? So that is A, B, and D. So A, B, and D, right? So which relation is not correct? So A, B, and D relation is not correct. So only the correct equation is this, right? So this is only what we get. That is K1 dash upon K1 is greater than K2 dash upon K2. So the three options, that is option number A, B, and D are incorrect. They are not correct according to this. Okay, good. Now move to the next question. Yes, that is xenon tetrafluoride, that is XeF4. XeF4. So XeF4 are tetrahedral and act as a fluorine donor with SbF5. Square planar. So let me first draw the shape using the whisper theory. So we know that XeF4. So there is a four bond pair. And how many lone pair? Xe having 8 electrons. So out of 4, they are the bond pair. So 4 electrons with 2 lone pair. So this will belong in the case of AB6. We know that what is the shape of AB6 square, right? And we have a two lone pair. Lone pair like this, one is here, one is here. So what is the shape? The shape is nothing but square plane. Square plane. So from Whisper theory, we predict the shape, that is square planar. So this one is incorrect. This one is also incorrect. So out of B and C only, either both are correct or only one are correct. So let's see, that is which of the following is correct, right? So seesaw shape and act as a fluorine, no. Square planar, and the one is a tetrahedral. So tetrahedral, right? So one option is also there, that is tetrahedral. Okay, so tetrahedral also possible. So tetrahedral and act as a fluorine donor with SbF5. Square planar and act as a fluorine donor with PF5. And a square planar and act as a fluorine donor with NaF. So these all three, any rest of fourth option, that is seesaw shape, except this AC, right? That is xenon fluoride R. So you can say that for xenon fluoride, right? For xenon fluoride, which of the following option is correct? You have to identify the correct option here. So seesaw is not possible. Tetrahedral, we can't say because this is a square planar shape, na? So tetrahedral is also not possible. So out of B and C, only one shape is possible. So which one is possible? Square planar and act as a fluoride donor atom with PF5. Yes, square planar and act as a fluoride donor with NaF. So obvious it is B, right? So obvious it is B. That is a square planar and act as a fluoride donor with the PF5. So XeF4 is a square planar and don't need fluorine PF5 to give PF6, right? So this is how we can draw. So only the correct option is B here. Now, move to the 28th question, right? So what the question asks, which of the following statement is are correct? So you have to identify the correct statement according to this. First, SS bond is present in S2, S2O6. So whether the SS bond is present in S2, S2O6 or not? Yes. So in case of S2O6 or H2, SS bond is present. So how will you draw the diagram? Like SS2OH. So we have a 2OH and rest 4 oxygen we have. So 2 oxygen here. 2 oxygen we have here. Right. So there would 4 and 5 is 6 oxygen and this is the SS bond. 2 to 4, 1, 5, 1, 6. Right. So this is the structure of S2, S2O6. So yes, there is a SS bond is present in S2, S2O6. In peroxo monosulfuric acid, S2SO5, sulfur is in plus 6 oxidation state. Whether it is correct or not? Yes. In H2SO5, the fluorine sulfur is in a +6 oxidation state. How it will in +6 oxidation state? Can anyone? Yes, they having a structure like S double bond O, and this is OH, OH. So +2 +2 4 +5 +6. So they having +6 oxidation state. So this is also correct. So in peroxo monosulfuric acid H2SO5, sulfur is in +6 oxidation state. Iron powder along Al2O3 and K2 used as a catalyst in the preparation of NH3. No, so we are not using aluminum trioxide and K2O in preparation of Haber process. Change in enthalpy is positive for the preparation of SO3 by the catalytic oxidation of SO2. No, because when we prepare SO2 plus O2, this will give us 2SO3, right? So here we can observe that the change in enthalpy is positive. So no, the change in enthalpy is negative here. In case of ammonia, also the change in enthalpy is negative, here also negative. So only the two options, that is A and B, right? So only A and B are the correct one. Rest all are incorrect. Okay. So this question is from the hydrogen chapter, right? So which of the following orders are correct? So the order is like DiH2, BH2, CH2. So these all are the metallic hydrides or saline hydride, right? Saline or ionic hydride. So they are the example of saline or ionic hydride of group 2. So we know that group 2 having beta Mangekar, that is beryllium, magnesium, calcium, right? So beryllium, magnesium, and calcium. So which of the following order are correct? So whether the electrical orders are correct or not. So we know that magnesium MgH2 correct electrical order are MgH2. This one is the correct relationship, right? BH2 having the lowest one and the BH2 having the highest one. So in this, they are saying like B is 2, C is 2, and that is Ti is 2. So where is from titanium. So titanium is basically from the D block. So they having a less electrical conductivity as compared to this two. So this order is very, very incorrect, right? Next, LiH, NaH, KH, ionic character. So for that would be used ionic for ionic character. Size of cation should be large. Anion. The size of cation should be large. Yani K, Na, and Li. So this is very much correct. Right. So this is correct. FFHSDD bond dissociation enthalpy. So fluorine being the smallest size and high repulsion, that's why they are easily broke. So this is also correct. H2O, MgH2, and NaH reducing character. So this is also correct because NaH has good in reducing nature, then metallic hydride, and then after non-metallic. So this is also correct. So the option number B, C, and D, right? These three are correct answers, right? So the option number B, C, and D all are correct answers for this question. No, that is question number 31, right? So in the question number 31, what you need to identify, calculate the pH. So you have to calculate the pH, right? So you have to calculate the pH at which this will take place. So how will you calculate this? Calculate the pH at which the following convergence reaction will be equilibrium in the basic medium I2 negative to I2 plus IO3. So first of all, we need to balance this equation, then only we were able to calculate. Okay. Let's see. So first of all, calculate the pH at which the following conversion reaction will be equilibrium in the basic medium. I2, I negative, IO3, where the equilibrium concentration at 300 Kelvin is 0.10 molar, and this is given. Given that delta G is minus this and this one, so you have to calculate the pH. So first of all, you need to balance the equation in the basic medium. So what is the equation is basically, so its equation is basically nothing but 3I2 plus 6 OH negative, right? So 6I2 plus 6 OH negative, 3I2 plus 6 OH negative, and this will gives us 5I negative, IO3 negative, plus 3H2. Okay. Now, so this is the balanced chemical equation we have. Now, calculate delta G. So how will you calculate delta G basically? So delta G naught is nothing, but just put the value. It is 5 into concentration of I, that is nothing but minus 15, right? Plus IO3 having value minus 123.5. Similar, H2O having value minus 233. Okay. Minus iodine is in solid phase. So its value is 0, right? Minus 6 into OH. So OH having value minus 150. Okay. So on solving, what you will get? You will get delta G naught is equal to minus 172.5 kilojoule per mole. Okay. So this is the delta G naught. So delta G naught is what? Minus 172.5 kilojoule per mole. Okay. Now convert this. So how will you convert this beta? So we'll convert this as minus 25 upon 3 into 300 into 2.303 10 raised to the power minus 3 log k. So we just put the value of log k, right? Log k is equal to nothing but RT ln k. Okay. So just by using the equation. So from here, because we know the delta G, we know this formula as well. This is nothing but RT and this is ln k or this is log k, right? So we can use this RT ln k. We are using the formula like RT ln k. For converting ln into log, we multiply by 2.033, right? So from here, we know the delta G, which is nothing but 172.5. So this will cancel out and we'll get log K. So log K comes out to be 30. Log K comes out to be 30. So log K is nothing but 30. So how will you solve this actually? So we know that log K is equal to 30, or we say 10 raised to the power 30 is equal to 10 raised to the power minus 5, 10 raised to the power minus 1 into the concentration of OH. So we just put the value of K, right? What is K? So K is like this. So from here, we calculate the concentration of OH, which comes out to be 10 to power minus 6. So if the POH is 6, then pH is what? Then pH is nothing but 8, right? Because POH is 6. So if the POH is 6, then pH itself comes out to be 8, because 8 plus 6 is equal to 14. So I hope you understand this question. What the question basically asks. So in this question, delta G is equal to given for the everyone, that is for I negative ion, IO3 negative ion, H2O, R values is also given. So just use the formula. So just by using the formula, we can actually calculate this value. I hope समझ आया सबको ये, ठीक है? चलो नेक्स्ट क्वेश्चन देखो बेटा. नेक्स्ट क्वेश्चन क्या था ये वाला 32. So 32 are basically how many of the following statements are correct. So in this question they are generally asking about how many of the following statements are correct. In CCP cubic close packing, the distance between the two nearest octahedral voids is 2r. In CCPP, distance between the nearest tetrahedral and octahedral voids is under root 2r. In CCP, distance between the two nearest void is under root 2r. In CCP, distance between next nearest tetrahedral voids and the furthest octahedral void is under root 5r. Right. So you have to identify how many of the following statements are correct. Right. So how many of the following statements are correct, beta, basically? So out of only 1 and 3rd, Right, that is one and third option are correct. So we can say that only two. So how many of the following statement are correct? So only two statement, that is first and third, are correct. Now move to the question number 33. What the question asks? From the following reaction, that is the reaction is going on like CH3 CHO plus XCl2. This react with NaOH to give CH3 CHCONA Hofmann reaction, where X is a minimum possible integer. Right. Now, Y react with the Y number of formaldehyde plus Z amount of NH3 eutropium used to treat chronic urinary tract infection. So you have to find out X plus Y plus Z. So first of all, you need to find the value of X. What is this X? So here, as we can say that X is nothing, but X is here 3. How can you say that X is 3? Because if 3 Cl2 are present, only then 3 Cl is like here, like. So this will become 2 Cl3, 2 Cl3. It will become Cl6, 2 CHCOON. So X is nothing but 3. What is Y? So Y mole of formaldehyde react with the Y mole of ammonia. So here Y is nothing but 6 and Z is equal to 4. Right. So Y is equal to 6 and Z is equal to 4. So how will you get the answer? Find X plus Y plus Z. So X is equal to 3, Y is equal to 6, Z is equal to 4. So X is equal to what, beta? 3. So this is 6 plus 3, 9 divided by. So 4 to the 8, something 2, that is 2.25. So 2.25 is the final answer, right? So here X plus Y plus Z, it comes out to be how much, beta? It comes out to be X plus Y plus Z, where X is a 3 and Y is nothing but 6 and Z is equal to 4. So it comes out to be 2.25. Okay, so this is how will you solve the question. Now move to the next one, that is 34. How many of the following species of compound are more acidic than carbonic acid? So you have to identify how many of the following are more acidic than carbonic acid, right? So which of the following is the more acid than carbonic acid? The first is this. That is A. That is squaric acid. As you see, this is in form of a square, so also known as squaric acid. SO3H is also very good acidic in nature. So these are also good acidic. Carboxylic group is great acidic character, right? So A, B, and C. A, B, and C. Anyone rest? That is NO2 also increase the acidic character. And E, that is phenol. So this is, no, this is, that is AB, right? D. And this one is also increased. This is not acidic in nature. So this is more acidic than carbonic acid. So squaric acid, sulfonyl group, carboxylic group, NO2 group, 2,4,6 trinitrophenol, or वो say 2,4 trinitro, 2,4 dinitrophenol. So these all are the no more acidic than carbonic acid. So the total number is nothing but 1, 2, 3, 4, and 5. So total number is equal to 5. So total 5 out of the following are good acidic in nature. Now, question number 35. So what's the question number 35 basically asks? What is the, basically this is a numerical question, right? So what is the question asked me now? 50 ml of water sample containing temporary hardness only required 0.1 ml of M by 50 HCl, right? For a complete neutralization. Calculate the temporary hardness of water in ppm. So you have to calculate the temporary hardness of water in ppm, right? So you have to calculate this temporary hardness. Okay. So what is this? 50 ml of water sample containing temporary hardness only requires 0.1 ml of M by 50 HCl. For complete utilization, calculate the temporary hardness of water in the ppm. So how will you calculate this basically? So this is nothing but you have to calculate the value, right? How will you calculate? We know that this is the molarity equation, M1 V1 is equal to M2 and V2. So here M1 is volume is 50 and M1 you need to calculate, right? Here it is already given 0.1 ml and the molarity is nothing but 1 by 50, m by 50 na, and this is 0.1. So what is M1 comes out to be? M1 is nothing but HCO3 negative. So it will comes out to be 1 upon 25 into 10 raised to the power 3. Right. So 1 upon 25 into 10 raised to the power 3. So let's assume if m moles of m moles of HCO3, F moles of HCO3 negative. What does it mean? It means 1 upon 25 10 की power 3 into 50. We can say that 1 upon 5. ठीक है? चलो. Similar, m moles of calcium plus 2, which is nothing but is equal to 1 upon 1000. M moles of CaCO3, m moles of CO3, that is equal to 1 upon 1000 into 10 की power 3 right. So this will comes out to be 10 raised to the power minus 4. So how will you calculate hardness? Do you know? We already discussed this formula. So how will you calculate hardness? So hardness we can calculate by weight of CaCO3 upon the weight of water into 10 to the power 6. So this is nothing but weight of CaCO3 divided by weight of water right. So weight of CaCO3 divided by weight of water, which is equal to nothing but 10 to the power minus 4 upon 50 into 10 to the power 6. So it comes out to be 2 ppm. So 2 parts per million is the correct. 2 parts per million is the correct answer for this question, right? So the temporary hardness of water in ppm comes out to be 2 ppm. Okay. So this is the correct answer for this question. I hope you understand this. Now, move to the next question, that is 36 one. So what the question asks basically, if X and Y are the total number of metal electrons which are present in the non-axial and axial set of d orbital respectively in the nickel cation, nickel DMG2, then calculate the value of x square y square upon x square minus y square. Okay. So what is X and Y? X and Y are the total number of metal electrons which are present in non-axial and the axial set. So we know that what is X and what is Y comes out to be basically, and how will it will come out. So by using, we know that in case of NIDMG2 and non-axial axial they are talking about. So what basically the idea is here, x square plus y square divided by x square minus y. ठीक है? X square plus y square upon divided by x square minus y square. This is what? This is nothing but 36 plus 4, and this is nothing but 36 minus. So it comes out to be 40 plus 32. Or we say it comes out to be 10 by 8, or we say 1 by 2. ठीक है? 1.25. So this is how will you get this? X square plus y square upon x square minus y square. That is 36 plus 4 upon 36 minus 4. That is 1.25. So this the correct answer is 1.25. Right. So this is only the correct option for this. Okay. So this is how we can actually solve such question. Now, move to paper 2, right? So we are going to solve some question in the paper 2 already. So how will you solve such question? So basically, the first question is, in an atom, maximum number of electron having the quantum number n is equal to 4, right? So you have to identify the, in an atom, maximum number of electron having quantum number n is equal to 4, and ml is equal to 2, and ms is equal to 1 by 2. So here n is equal to 4, right? So already given n is equal to 4. ml is also given and which is equal to 2 only. So it having only 2 orbitals. So n4, it may be, right? N4 means what? L may be 0, 1, 2 or 3. So L may be this value, right? 0, 1, 2, 3. Now, also one important condition here, that is ms plus 1 by 2 and ml is equal to only 2. So d2 orbital having 4 electron, right? F2 orbital having 4 electron. The total 8 electrons are present, right? So out of these, you have to identify now. So we know that this is not S, because S having only one orbital, they having a 2 orbital. This is P, this and this, right? So the you are equal to the, this one is incorrect, right? Because they do not have a 10 electrons. How many? Because d orbital, d 2 orbital, 4e electron, f 2 orbitals, 4e electrons, right? So total number of electrons is nothing but 8. Okay? The total number of electron is nothing but 8. How will you get this? Na? ml is equal to 2. ml is equal to 2 means nothing, but ml is equal to -2, -1, 0, 1, and 2. Like this, right? So like this only we get. Now for Ma2, B2, C2, total 6 Gi we have, right? Total 6 Gi. So it is the correct option, B and D. That is total number of 5D substrate electron metal is PTCl5. So the total number of 5D substrate electron in the metal here is PTCl4. Okay. Now, question number 20. Which one of the following statement is incorrect? So O2 is paramagnetic, but O3 is also paramagnetic. Yeah, this is true. Right? We know that O2 is a paramagnetic due to MOT theory. Right? So MOT theory, we understand this. The O2 is a paramagnetic due to presence of two unpaired electron into pi star 2px and pi star 2py. But O3 is a diamagnetic. So O3 is a diamagnetic. It's not paramagnetic. Right. So O3 is a diamagnetic. Now, higher atomic molecular orbital of O2 is graded, right? Graded. Any HOMO of this is graded. So this is incorrect. Whether it is incorrect or not? No, this is correct, right? Next, B B2 is a paramagnetic where C2 is also paramagnetic. So B2 we have how many electrons? Boron we have a 10 electrons, right? And carbon we have a 12 electrons. So B2 and C2. So these are the wrong statement because B2 is a paramagnetic having 12 pair electron and C2 is a diamagnetic. So C2 is a diamagnetic, not paramagnetic, right? So this is also incorrect. In B2 and F2, sp mixing taking place. So obviously up to N2, sp mixing is taking place. So up to the N2 nitrogen till nitrogen, sp mixing is taking place. So that is yeah. That is option A, C, and D. Option A and C, D are the incorrect. Okay. So these three options, that is option A, C, and D are the incorrect one. Now, move to the next question. That is the true or the correct statement for an organic compound having molecular formula CpS6 is the. So they having the molecular formula of C5 and S6 only. So what is this? Basically, the total open chain conjugated alkyl diene is possible to 2 only. The total possible cyclic isomer with the chiral center is 2. The total open chain isomerism possible is 4. And the total open chain optically active isomer possible is also 2. So all the statement that is 1, 2, 3, 4. So all 4 statements are true. Now, move to the next question. That is, in this question, reaction which involve the formation of the product which has a this group, benzoic acid group, right? So in which you get the group like this. Right? So in which you get like this, that is a benzoic group, a benzoic acid group, in which you get like, so let's see, that is in this, when you list of this, and when the phenol undergo annihilation CO2, we know that this is known as the cold reaction. So when this is treated with attenuation CO2, high pressure and temperature, NH plus, it will form this benzoic acid. Right. So only A and D will form the benzoic acid. Now again this question comes. This is from the again quantum number. Psi is NR 6 minus Z, E minus Z are 3 cos theta. Proposed hydrogenic wave function where Z is the atomic number, R is the radial distance from the surface, and theta is the azimuthal line. So psi is 0 in the xy plane. So you have to identify the following thing. From the given hydrogenic wave function, it is clear that n is nothing but 3. Right. From this, Z are 3 cos theta. So n is nothing but 3 and L is equal to 1. So this is what we will get from this equation. So L is equal to 1 and the N is equal to 3. This is all we have. So we have an angular node. So how many of angular node we have? Angular node. L. Similar way, what is the radial node? N minus L minus 1. Right, N minus L minus 1. So it is also equal to N here is 3 minus 1 minus. So radial node also comes out to be 1 and angular node also comes out to be 1. So both radial and angular node is equal to 1 and 1. Okay. Now, so if the angular node is 1, radial node is 1. So the total node that is n minus 1 which is equal to 0. So the function phi is 0 in xy plane. Right. So which option is correct? That is option A, C, and D. So A, phi 0 in xy plane, one angular node is present in a yz plane. Right. Two radial nodes are present in this. So option A, C, and D. Right. So A, C, and D are the absolutely correct. Next question. Which reaction out of the following involve formation of a hydrocarbon cyclic acyclic as a methyl? So you have to identify the reaction in which will form hydrocarbon, formation of a hydrocarbon, either a cyclic or cyclic, as a major product, right? So which are the major product that is in this one? and in this one, fine phosphorus. So in this all three, because in this we'll get aldehyde, right? This is Rosenmund reaction. This is the Rosenmund. So in Rosenmund we get the aldehyde, right? So in Rosenmund we get aldehyde. So rest all will get hydrocarbon cyclic as a major product. Now, which of the following reduction reactions are actually employed in a commercial extraction of the metal? So which of the basically following method that we are going to use, right? So the answer is, for this we use this, and this. That is ferric oxide, chromium trioxide, 2NaCl. This is what we are going to use. Okay. Now, what is question number 6? In how many way of the following case, gases is more compressible than the ideal gas? So you have to identify the cases, right? So in how many of the following cases, gases is more compressible than ideal gases, right? R is given. O2 gas has a density of 20 gram per liter at a 10 atm and 300 Kelvin. N2 gas has a 2 atm and 273 Kelvin, occupy molar volume of 6 liter. And gases A at its critical temperature and pressure lesser than the critical pressure, right? So let's see, let's understand this thing. We know that what is compressibility factor? So it is nothing. Or Z is equal to PM upon DRT. What is the value? 10, 32, 20, 1 by 12 into 300. Right? So it will comes out to be 16 by 25. O2 so negative deviation. Right? So O2 so negative deviation. Next, Z is 6 by 11.2. Next case, it means Z is less than 1. So if the Z is less than 1, it will show negative deviation, right? It will show negative deviation. And in option number C, will you observe that at show negative deviation, T is equal to critical temperature and P must be greater than less than critical pressure. And for the D option, when the pressure is low, temperature is TB. When the temperature is low, temperature is only T. Okay, temperature is only TB. So Z is equal to 1. Or we can say T is greater than T. T is greater than TC is greater than T. Right. So we can say this. So which of the following option is correct for this beta? That is option number A, B, and C. Both three options, that is A, B, and C, are absolutely correct for this. Now, observe this question very carefully till I take some water and I try to do this. Okay. So, what the question are? Answer the following by appropriate matching the listed based on the information given in the paragraph. 1 degree alcohol on oxidation by the mild oxidizing agent produce aldehyde. We know that while the strong oxidizing agent can convert into the carboxylic acid is obtained. On the other hand, secondary alcohol with the mild oxidizing agent give ketone. and tertiary alcohol is reluctant to oxidize by the mild oxidizing agent. This we all know that, right? So incorrectly matched among the following you have to identify. So this is the alcohol, primary alcohol. This is, and it will convert it into alkene when we treat it with PCC and CH2Cl, right? So you know this. What happening basically here, that is alkene will be obtained only, right? Let me yeah, alkene will be obtained only if the copper, or we say 300 degrees Celsius is the rigid fuse, right? So this one is the correct one. The second one, that is the alkene obtained, that is this one, that is in first, that is option A, right? In option B also we have a structure like when we treated with KMnO4, this OH will be converted to O, right? And the third one, OH is, this is the primary alcohol is converted into carboxylic acid, and this is copper. So we know that this is absolutely incorrect. Why this is absolutely incorrect, beta? Because uh, double bond, when we obtain double bond, basically when this treated with copper and 300 degrees Celsius, right, 573 Kelvin, then only, right? So alkene will be obtained if copper and 300 is the reagent used. So the B option, that is the second ka P, second P is incorrectly matched. That is, if the second is matched with the P, this one is incorrectly matched, right? So always remember. Now, now move to the next question, right? That is 29. Okay. So what the question 29 basically asks from you, that is in this question, you have to identify the following, right? So you have to identify this following, and what the question is basically, the question is all about, they are asking match list one with the list two, right? List one with the list two, you have to match. Okay. So how will you match the list one with list two? This is chromium. So this is chromium NH36. This is copper. So correctly match among the following is. So you have to identify the which of the following is correctly matched. Okay. So just identify the correctly matched among the following. Okay. Now chromium NH3. So we know that chromium NH3 6 and having 3 plus ion. So we know that in this case, the geometry is what is this is a strong ligand. So it is like D2sp3, right? So the first is matched to S. So S is what here? S is diamagnetic. Okay. First is matched to S. Okay. And so S is diamagnetic. This is a diamagnetic or not? So yes, since this is a strong ligand, so it's supposed to be diamagnetic in nature, right? So this is correct. Uh, Next is copper NH36, like copper NH3 6, and this is plus 2, right? Plus 2. So you have to identify which one is correctly matched or not. So how will you identify it? Actually, this is the 29th question. Huh? Just wait for a minute. Right, just wait for a minute. That is question number one. From 19, we start the question. Well, let me check. Yeah. Right. Okay. So, correctly match among the following, right? So you have to identify the correctly matched. So in this, this is absolutely correctly matched. That is fourth. How? Because fourth in we have a IF6 and F is a weak ligand, right? F is a weak ligand. So it is a, it is a diamagnetic, right? So it is a diamagnetic. So what is the correct? So for A, the correct answer is RNT, right? For A, the correct is RNT. How will you say that RNT? Because here, if you're considering the A chromium one, this is RT, B is equal to QT, C is equal to PT, and DS. So we can match the question like this only. Okay. Now, in this only, that is question number this one. Next one, correctly match among the following is, that is C. That is second Q. How we can say that? Because we have a IF63 negative with having 0, 0 or 0 sp3d2 hybridization. So we know that whenever the ligand is strong, the hybridization is D2 sp3, and whenever the ligand is weak, hybridization is sp3d2. Whenever the ligand is strong, the splitting is more, delta O is more. Whenever the ligand is weak, the splitting is very much less, right? So correctly match among the following is, that is the second. How will you say that? Because copper NH3 6 and is belong to -6 and sp3d2 hybridization, right? sp3d2 hybridization. So this is absolutely correctly matched. Now, how many of the following statement is are correct? So you have to identify how many of the following statement is are correct out of the following, right? So you have to identify the how many of the basically following statements are the correct one. So let's see, that is, this is from the surface chemistry. So only the, that is fifth number and ninth, that is, by the gases mass, the poisonous gas are removed from air by charcoal using the process of adsorption, and the float flotation process is an application of adsorption. So these two, so only two statements are correct. Now move to the 36th question. Next one. So in this question, what they ask generally, X a black which is heated in dilute HCl, it will form white. When they are treated with Na2FeCl5NO, NOH, it will give a purple solution. Gas Y has been allowed to react with the following species in a neutral acidic medium. So then calculate the value of P minus Q upon R. So you have to calculate the value of P minus Q upon R, where P is the number of species which undergo the redox reaction with the gas Y, and Q is the number of species with which gas Y undergo precipitation, and R is the number of species with the gas Y produce no observable change. Right. So let's see the solution of each one in a detail. Like, let's see the first option. That is when the FeCl3, right? FeCl3 is treated with 2H2S, right? In the, it will give 2Fe, acidic medium. We are talking about the acidic medium. It will give 2Fe plus 2 sulfur, which is settled down, 4H plus, and 6 chlorine negatives. On the similar way, in case of B, when the copper sulfate is treated with H2S, it will give copper sulfide, which is in black, right? 2H plus and SO4 twice negative. Similarly, when the BaCl2 is treated with the H2S, when the BaCl2 is treated with H2S, it will give us Ba plus 2, 2Cl negative, 2H plus, and this is nothing but H2 negative, right? Similarly, when we treat SO2 plus 2HS, this will give us nothing but 2S plus 2H2, right? Similarly, in case of E, that is Cr2, O7 twice negative, when they are treated with acidic medium, it will convert it into 2Cr plus 3 plus S plus H2, that is 7H2, right? And similarly, when the CH3 CONA is treated with H2S, it will also convert it into 2CH3 COH plus 2N. Right. So from here we can say that out of which of the following, like Y represent the H2S. So we have a P is nothing but is equal to 3 here, Q is equal to 2 and R is equal to 2. So just put the value. So what we'll get, that is, in this question they are asking P minus Q upon R. So P minus Q. So P minus Q upon 2. 3 minus 2, 1 upon 2, which is equal to 0.5. Right? So 0.5 is the correct. So this is how we can actually solve this question. Right? Let's see one more question. So basically the question is, in the question they are asking, you have to calculate the, which question is this basically? Just wait for a second. Yes. This question is 35, that is 34. So in 34th question, they are basically asking how milligram of this will be required. So we know the formula, that is what we know the formula beta, that is 0.693, right? 0.693 upon K is equal to 2.303 upon K, that is 4 log N naught upon N. So here from this equation, N naught upon N naught is given, which is comes out to 1 upon root 2, right? So we know the value of this, that is comes out to be 60 into root 2, right? Upon 100. So this will comes out to be 0.8485 milligram. So 0.8485 milligram is the correct answer for this question. So I hope this is clear to you. So we'll discuss all this question in detail way. If you face any problem related to this question, let me discuss this thing once again. What you remember here, whenever the questions come from the CFSC, just remember the important thing here. The important thing here, if I'm talking about the CrNH363 plus, copper NH36 plus, and FeH2O6 plus, and iron NF63 plus. So in all this, F6 being and H2O being the weak ligand, right? So whenever the weak ligand, crystal splitting is be like this, right? So in case of octahedral, we get the 3 orbital like this is called T2G orbital. This is called EG orbital, right? And this is the energy gap. So whenever, remember this point, whenever the ligand is strong, whenever the ligand is strong, right? Then this energy gap, that is, this is also we represent as octahedral splitting. So this octahedral splitting is much more, right, than the pairing energy. And similar when the ligand is weak, right? Then delta O is less than P, or we can say that the splitting energy is less, right? Now, if the splitting energy is more, then what happens? Pairing start, or we say they will become diamagnetic in nature. They become diamagnetic in nature, and in this case, they become paramagnetic. Diamagnetic means they have a fully filled electrons like this, and paramagnetic means they have unpaired electrons, right? So they have a fully filled electrons and they have a unpaired. So these are like they behave like this only. So this point you must remember while solving any question related to the CFT. If you know this value, then you can easily solve this, right? Okay, I hope it is clear to you. So we already discussed questions, many questions related to this chapter, right? So we already covered the entire thing, entire chapter. Already discussed all the questions important, which is important to this chapter, right? So let's meet in the next class. We are going to start our new chapter, that is we already covered with, right? We already covered what that we are going to start the chemical kinetics and nuclear chemistry from the next class, right? We are already covered with the electrochemistry and more equivalent concept, structure of atom. So we already covered this thing. So from the next class, that is from tomorrow, we are going to start chemical kinetics and the nuclear chemistry. Okay. So from the next class, we are going to solve question related to this only. So that today for the, this is all for the today class. Now we meet in the next class where we're going to start the new things, right? So take care till and try to solve this question again and learn from this. Okay. So let's meet in the next class where we're discussing all this thing.